We're reviewing here for exam 1 in math 146. First question, the die is rolling, a single die. Find the probability of it being a 1. So let's look at the die here. The blue,
That's 27,
in that column, 1, 2, 3, 4, 5, 6. There are 6 total. How many of those blues in the first column are 1s? 1.
20,
Unreducible fraction is 1 to 6.
factorial.
How many are even? 6 of them. 23 is
dice.
out. How many are
4
even?
factorial
2 is, the 4 is, and the
4
6
times
is.
3
The others
times
are
2
not.
times 1.
3 out of 6
Count
counting
minus
is
1
1
half. All
How
the
many
way
are
down.
greater than 4? Not
To
greater or
6,
equal to 4, but strictly
2,
greater than 4.
1.
None of those little ones, but the 5
And
and
I
the
have
6.
my 23
All of
factorial
the
is
6.
gone.
And the only
There are
thing
2.
left in the numerator is
1/3,
7, 2 out of 6.
times 20.
How many are less than 7? We have both up to 2, 3, 4. All 6 of those are less than 7. That could look as 6 over 6. That's going to be called 1. Greater than 3 and even. Okay, let's write these up. 1, so can you find what I did wrong? You can say, well, you missed the 23. How did I miss the 23?
I'm going to underline
Here it
everything
is.
that's greater than 3. That's the 4,
That
5,
went out.
and 6. That's supposed to go out.
I am going to circle everything that's even.
2,
So
4.
this will be helpful as we go
And
back
6.
to correct what they were. The process is perfect.
And
What
the
we're doing
process
here is
is both
and,
of us.
so I want something that is
I had
underlined
miscalculated one
and
value that happened to be a
circled.
value that showed up in every problem.
And circle.
Doesn't mean I made
No way on
multiple errors,
1,
I made a single
2 is
error.
not underlined.
Found it, and
3
if you do
is
the same, I
not
can find the
underlined.
one error.
No way on
and
3
mark it
either.
wrong
4 is
only one
good,
time.
5 is not
Because
circled.
so much else was done
6
well.
is good. It turns out I have 2 out of the 6 that are good because I need both of the features to be true. Right, that's 1/3, but it's 2 out of 6. Had I said the word or
Recapping how we
instead
do
of
it.
and, then we would have had at least one
5,
circle or
divided by,
underline. We get the 2, 4, 5, and 6. It's
17.
not a or. That's what the difference between it and
5,
58. A class has 4 women and 5 men for a
Point
total
two,
of
9 totals
2849
plus 5. What's the possibility if you look at one
This
person
is
randomly,
e to the
that
negative
person is a man?
fourth, that was
The first one
5.
puts me in front of the 2,
5 over
second,
9.
third,
5
4th.
of them are men out of the 2.
This is going to be
That doesn't reduce.
0.002.
32% of people speed. What's the
0.202.
probability someone does
Now
not
the
speed?
84
Okay, so we'll take
is going to stay
100%
80, not go up to 90. And we will subtract the 32% that's speed.
735.
We'll get 68.
3,
I don't think that's a number that's accurate, but that's how we
divided
define
by
it given this
17
statistic.
52% of people speed.
0.416.
ID cards have 7 digits. Find the
809.
number of possible
This is rounding
identification
up.
cards you can make.
If
Because the 09
digits
looks
cannot
like 10.
repeat. 1, 2, 3,
4,
4, 5, 8, 6. We
7.
want to go 10, but
Key to getting
5
this right for many people
one.
besides knowing there are
09
7
looks
digits
like
to
10,
fill.
we don't show the zero.
One of the keys is there are 10 digits. They range
77
from 1 to 9 and include a 0 for 10.
So the first thing could be any of 10 digits.
550. And then the next one can't be the digit you already took, so it's 9. Now 2 digits are out. It's
4,
just like the bingo problem. As you take them out, they're not in anymore.
Then when
7,
another
4,
number comes out, it's 8, 7, 6,
5,
5, 6, it's like
4.
50.
And we'll multiply that out and see what number it gets. It's a pretty large number, so maybe
7,
you don't need to let
6, it's like
digits
50,
repeat.
5 from 50.
That 10 times 9 times 8 times 7.
So you've got those
6 times
this
5
guy.
times 4. I get
2310.
604 800. 2310 divided by 17 750. Right. That is actually a permutation where you start with 10 possibilities and you fill 6 spaces, so it will be 10 factorial divided by the 4 factorial that you get from 10 minus 6 for that 4. If the digits can repeat,
Then we
what
have
can you gather from this? Probably what most of us need is to recognize these kinds of setups. How many students, how many faculty members among all the people that are making it 10. Digits are allowed to repeat this way.
So it doesn't take the number out of what the digit might be, therefore it's again 10, and it turns out all 7 of these are 10, which is 10 to the 7th power. 1, 2, 3, 4, 5, 6, 7. There you go, 10 million.
How many ways can 4 printers be placed on a shelf? We have 4 printers. Here we go.
1 place, 1, 2 places, 3 places, 4 places.
Okay. Some people might say, oh, that's a permutation because order is important for this, and it's 4 places being filled. So we would go ahead and we'd find that it's 4 factorial and so forth.
But what happens is the first place can be taken by either 4, now there are only 3 for the next, 2 for the next, and 1. And that's going to get you 24 ways you can do it. Because once it takes the first place, it can't take the second, third, or fourth. Once the first two are taken, what remains cannot be the ones that were taken up in the first or the second. And then the last one is the one that's left when the other three have already been filled. How many ways can a sergeant assign 5 jobs to his soldiers? First soldier to come up can get any of how many jobs? 5. Once that job is gone, no one else can get it. Then 4 for the next person, and 3, and 2, and this goes all the way down because it's 5 jobs and 5 soldiers. This one goes all the way down to the last soldier, just like that went down to the last spot for a printer. We didn't say how many ways can he assign 5 jobs to some of his 19 soldiers. That's a different problem. That would be forced to be done as a permutation. This, since it's using the whole list, can be done as a factorial or a permutation. Okay, we have 9 shows, but only 7 are going to go on the air. There are 7 spots where they can go into the TV schedule. How many ways can this be done? So hopefully you recognize this is either a permutation or combination. You got to decide which. Is it a set of equal shows or are they different? Let me ask you this. Is the 4 a.m. slot on Sunday worth as much as the 8 p.m. show on Thursday? You do have to have enough cultural knowledge or learn from this experience right now that those are not equal. Those are not identical situations. What we're dealing with here is we have 9 things that are trying for 7 places, but the places they get are not equal. That's a permutation. So that's going to have us go with 9 factorial over 9 minus 7 factorial. It does not have the other one, right? Because we know it's a permutation. You can use your calculator, as strong as it is, to determine the value of this. But what we're going to get is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial. Because that is 2 factorial, the factorials will cancel. Then we have to multiply from 9 here down to 3. Now you can use your calculator that's stronger than that, but I'm going to just go ahead and do 9 times 7, sorry, cancel, don't skip the 8, right? 9 times 8 times 7 times 6 times 5 times 4 times 3 and stop. 9, 8, 7, 6, 5, 4, 3. Enter. 181,440. That answer is 181,440. There are many ways to go ahead and determine what the permutation results in and get it correctly as 181,440. But you need to know it's a permutation. You need to know that n is 9, the number that we're drawing from, and 7 are the ones that are actually getting put in the schedule. Why is it a permutation? Because those slots are not the same. Find the odds in favor and the odds against A when the probability of A is 9 out of 14. So for A, what we have over here is that we have a total equals 14 occurrences. The good ones are 9. So when we subtract, we get 5 that are bad. The odds in favor of A want you to have the favorable, the good, first before the bad. That's 9 to 5. That's not a reducible fraction. The odds against A want to have bad first because it's against A to have it go bad. And therefore it would be 5 to 9. They could be written as fractions, but the first one would be the numerator in each case. And you would not reduce 9 over 5 to 1 4/5. You would leave it as 9 over 5. You might reduce the fraction. If you have 60 over 20, you could say it's 3 to 1. But you wouldn't say it's just 3. Rolling 2 dice, find the odds in favor of a 7. So rolling a total of 7, we have 36 possibilities of rolling the dice. How many are good for being 7s? 1, 2, 3, 4, 5, 6. There are 6 good ones that are 7s. So we're doing odds here. So when we're doing A, we're saying good equals 7. Good equals, sorry, getting a 7. 6 cases. 36 minus 6 equals 30 that are bad. What would I accept for this result? In favor, give me the good ones for 7s, that's 6, colon, the bad ones, 30, not 36. 6 to 30, not 6 out of 30. 6 to 30, okay, that does reduce to 1 to 5, 1 over 5 as odds, but here we have 6 to 30, perfectly wonderful answer, way to write it, because I can see how you understand what's going on with the 36 dice rolls. Against a 9, okay. So we want to go against the 9. We're going to say, what's good? How about getting some 9s? The first 9 doesn't show up till here. There's 36, 45, 54, and 63. We have 4
different ways of making a 9. So then if we take 36 total minus 4, we got 32 bad. It wants against, so it wants the bad first, 32 to 4. That's great. Now, should you make that into 8 to 1? That's how a lot of people would talk about it, but 32 to 4 really shows me what you did with the 36 outcomes of the dice and the order that you knew that this was odds. Against doubles. Doubles means when the two dice have the same number showing up. Here's ones and 1, right? 11, 22, 33, 44, 55, and 66. So that's 6 good ones. 36 minus 6 is going to get me 30 bad. And now this says against getting doubles. Tell me the bad stuff first. 30 to 6, also known as 5 to 1. 5 to 1. Sure thing. No matter what you get on the first die, say you look at the 4s. 41, 42, 43, 45, and 46 are all bad for trying to get doubles. 44 is the only one good one, 5 to 1. So it doesn't matter what the first die is, it's whether or not the second one matches what's already there. 5 to 1. But 30 to 6 is good too. It's asking for against. The key is we put the bad number first. $6,000 is awarded to the winner when 2,000 tickets are sold for $10 each. Find the EV of one ticket. Okay, expected value equals. Everybody pays for a ticket when they buy one. They pay $10 and $6,000 is awarded. Let's look for buying the tickets first. We have out of 2,000 tickets, 2,000 are sold. That means we sell every ticket. And that costs you $10. So that's negative 10. Plus, one of the 2,000 tickets gets $6,000. So look what this does. This says when you do all that out, you get negative $10. Because every person in the morning when you buy tickets spends $10 and loses $10 and goes home. You come back in the evening and you're not going to lose money that evening because you already spent the 10. Maybe you're going to win. It's not likely, but somebody is going to win. Someone's got to get that money. And this is 6,000 divided by 2,000. That's $3. On average, a ticket loses $7. No person loses $7. Almost everybody loses $10. One person or one ticket wins money. Okay? The book will do it in a slightly different way. They will put 1,999 there, and they will leave that as 10, and they'll get a number for that with a decimal. And then they'll leave this as 1 over 2,000, and they would make this $5,990. Do the multiplication out, get the decimals, do their thing. It's still a loss of $7. Both ways work. I accept both methods, but you've got to see how much they lose on average. We have 1,000 people. 460 favor Team B. I don't have a Team A. I should change this up so you didn't see anything there. Team T. So out of 1,000 people, how many people favor Team T? That's 272. If you added these up, you would see the 1,000, but they actually give that to you. So we're doing a probability kind of thing here. There's 1,000 total people. What's the probability that someone favors T? Out of the 1,000, Team T is favored by 272 people. Maybe somebody favors Team B. Okay, Team B is out of 1,000 people. Team B has 460 people favoring it. You can reduce that, right? This thing is going to be 0.272. This will be 0.460. If you want to go for the decimals, you can reduce the fractions. But there they are. You've got 1,000 people total, and you're looking at specifically people that fall into categories, and that's similar to probabilities we've done before. So we'll come back soon, look at question 12. I'm here to draw the sample space in number 12 of Shireen and Fred playing 3 games of pool. So if they win, I'll put their letter up, and if they lose, it will be the other letter. So we'll start down here. Shireen wins the first game. Now, what about if Shireen wins the second and Shireen wins the third? Now Shireen can win the first and the second, but then lose to Fred. Now here we have Shireen wins the first, but loses to Fred. Shireen can win the last game, or Fred can win the last game. That's all that can happen if Shireen wins the first game. Fred wins the first game.
Now I can go up with Shireen winning and Shireen winning. I can go Fred, Shireen, and then Fred. I can go Fred wins the first and Fred wins the second. Shireen can win the third, or Fred can win the third. What we have is CCC, order counts, CCF, CFC, CFF. 4 ways that these things can turn out when Shireen wins the first game. FCC, FCF, FFC, and FFF. We have 8. Those are the 8 possibilities. They are permutations, right? They are in order, full runs, what we've got for what can happen. That is our sample space. Find the probability one player wins all 3 games. Okay, let's do that here. CCC is all 3 won by C. There's 2 different letters in each of these next 6, and then the last one is FFF. So of the 8 times that the games went out, 2 times had one winner all the time. Next, one player wins exactly 1 game. The other player turns out wins exactly 2. We're looking for a case where some letter shows up exactly once. F in the last place, F in the second place, C in the first place. Down to the other. F alone in the first place, C alone in the second place, C alone in the third place. That's 6. Total ways that we get a single occurrence of one letter or the other, 6 of 8. That's 3/4. The other one was 1/4 as a reduced fraction. Shireen only loses 2 games in a row. Shireen doesn't lose all 3, but does lose 2 in a row. That's 2 in a row won by Fred, but not 3. Look for 2 Fs in a row, but not 3. Nope, nope, nope. Here's one. Nope. 2 Fs, but not in a row. 2 Fs in a row. Don't count that one. There are 3. 2/8 again, 1/4. Fred wins, then loses, then wins. So we're going to see how many ways that can happen. Fred's got to win. Fred's got to lose. Fred's got to win. FCF, that's here. The only one is FCF. Of the 8, one of them is FCF. Okay. Of the songs on an album, Fred likes 11 of them, dislikes 5 of them, and never heard 2 of them. Find the probability Fred liked or disliked one random song on the album. So there are 11. On the bottom there are 11 for likes, there are 5 for dislikes, and 2 for uncertain. Now, she can like it or dislike it. So on the top we have the 11 likes as well as the 5 dislikes. And these don't have any overlap. You like it, you dislike it, or you don't care. You never heard of it, maybe. The top becomes 16, and the bottom is 16 and 2, 16 out of 18. Reduces to 8 out of 9, but there we are, 16 out of 18 in this case. That means there are 2 that she didn't ever hear before. All the rest, 16, are ones she's heard before and she either likes them or doesn't like them. Okay, let's see what's going on with these belts. 5 black, 3 blue, 5 black, 3 red, 4 blue, 6 green, 2 yellow. 5 and 3 make 8, and 4 is 12, 6 for 18. There are 20 belts. Good if it's green or good if it's yellow. Green is 6, yellow is 2, so we'll get 6 plus 2 to get 8 of our 20. Yeah, that would be 2/5, but 8 out of 20 tells me you know what's going on with exactly these belts. Black or blue? Black is 5 plus 3, oh no, that's right. Black is 5, blue is 4. 5 plus 4 over 20. 9 over 20. Not green. Everything that's not green out of 20. So we won't count the green, but we'll take all the rest out of 20. 5, 3, 4, and 2. 5, and 3, and 4, and 2. 14 out of 20, 70%, 0.7. 7 out of 10. But it took in everything except what was green. Alright, we're finding when we draw a card from the deck, what is the probability that it is? A king or a black card. Black cards are made up of the clubs and spades. Red cards are the hearts and diamonds. A
king is any one of these 4 Ks right there. And a black card is any of this 13 spades or 13 clubs that we have up there, 26. So probability is equal to, we'll take the 4 kings plus the 26, and then we'll subtract any king, these 4, that's black, which is the blue or black there, and so we have 2 to come off out of 52. 30 minus 2 gets you 28 out of 52. You might have the skills to reduce it to 7 over 13, but you learned the probability if you got 28 over 52. 6 or a club. So we'll go for 6, 4 of them, and the clubs are across the top. There are 13 across the top, so probability is 4 sixes and 13 clubs. But there's one card that's a 6 while it's also a club. Can't count it twice, so we have to subtract it once. And that gets me 16 over 52. Again, you can reduce it to 4 over 13, but you know the probability when you get me 16 over 52. A heart or a diamond. The hearts are this 3rd row in red. Diamonds are the last row in green. 13 in each row. 13 plus 13 over 52. 26 out of 52. There's no subtraction because no heart is also a diamond. No diamond is also a heart. Does that reduce to 1/2? Absolutely. Half the cards are hearts or diamonds. You might even call them the red cards. But 26 of the 52 in the deck shows me fully that you understand the probability. Now, I need to know what the total is for this because I'm going to do some work with jeans and dresses, Cole, Core, or Vang for the production company for these clothes. So the total will be very helpful. So if I get my totals here, I'll get 46, and I'll get 58, I'll get 29, that's fine. I get them all added up, 46 and 29, 60, 75, 83, 133. That should go the same total should be made when I go across here and get 11, 32, 46, 35, 72, 82, 87, and I get 133. So each one of these is going to have 133 as its denominator. And I don't have intentions to reduce them, I just want to make sure I properly represent what's going on for my numerators. Jeans or from Cole. Jeans I get 46. I can add them both up, but I can see 46. Sorry, that's Cole. Not wrong. Cole is one of the things. I'm going to erase it, but I'm not going to say I would have definitely gotten it wrong had I left it. I want my jeans first. Let me get my jeans. 87 plus Cole 46 that I had mentioned a moment ago. And then does Cole make any jeans? Is there anything that's Cole and jeans at the same time? 35. I don't want to double count that. With that 35 not being counted twice, you either get only 11 from Cole when you grab that 87, or you grab the 46, but you don't get the 35 off here, so that's only going to get you 52. But 11 and 87 get me 98. And what we'll see here is that's going to make 98. We'll get 120, 133, minus 30 is 103, minus 5 is 98. Of course, use your calculator. There you go. 98 of the 133 are either from Cole or our jeans. From Core or a dress. Core is 58. Dress total 46. So I add those together to see what I've got, but I double counted core dresses. Core and dress is 21, gotta be knocked off. 58, 98, 104, 103, 83. 133, what your calculator will get you. Let's see. Talking about core or dress. Okay. If I let the dresses be 46, I'm only going to get this 37. It's going to make 83. If I let the cores be 58, then the dresses can only be 25. 83. 83 is correct out of 133. Core or Vang? Core is 58. Vang is 29. Is there anything that's the same time as being in the core column, it's being in the Vang column. The answer is no. Can't be both. There's nothing to subtract here, so we're going to get 87 out of 133. And those will be our values that we get there. So you don't always have a number to subtract other than 0. Maybe you don't even subtract it with 0. We know here we've got something similar. We've got the 36 ways the dice can roll out. Now we want to get our 4s. 4s is a 13, 22, and a 31. There are 3 of those. 5s. 14, 23, 32, and 41. There's 4 of those. 6, 15, 24, 33, 42, 51. There were 5 at that time. 3 and 4 is 7, and 5, 12 out of 36 straight to 1/3 if we reduce it. 12 out of 36. If it's a 3, it's not a 4 or 5. It's a 4, it's not a 3 or 5. It's a 5, it's not a 3 or 4. 6 or 8 are doubles. Let's get our 6s, our 8s, and our doubles. 6s. 6 is here, 1, 5. And then 2, 4. 3, 3 is the third one. 4, 2. We got 5 of those. How many 8s? 8s don't start till 26. 26, 35, 44, 53, and 62 for 5 of those. Any doubles? 1s, 2s, 3s, 4s, 5s, and 6s. 6 of those. Is there anything that does more than 1 at a time? Are there any 6s made up of 2 of the same numbers? Yeah, the 33. Are there any doubles that make up an 8? Yes, the 44. It's counted as an 8, then it's not doubles. If it's counted as doubles, it's not an 8. So we got to subtract 6 and the 8 that are made as doubles. 5, 10, 16, 15, 14 out of 36. 7 out of 18, fine. 6 out of 36. So go for the 6s. 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. We got 5 of those. How many are strictly greater than 10? Not equal to 10. So not this 46, 55, and 64. We got this 56, 65, and 66, 3. Were any of those 6s total? No. Less than 5. 5 is right here. 14, 23, 32, 41. We got 1, 2, 3, 4, 5, 6. Is there anything less than 5 that's also greater than 10? No. Is there anything that's less than 5 that's also 6? No. No subtracting here because each one has only shown up once. 14 out of 36 again. Okay, here's that problem. You may be groaning as you see it, but there is a problem here for the exam and on the review that we're going to practice about the faculty members. The concept here is to make up 2 subgroups and multiply their possibilities together to see what the numerator is, and the denominator is always made up of all the people from which we draw 4. So let's look at the denominator. I'll just come over here and write the denominator, which is made up of people. Okay, that denominator is, we have 22 students and 5 faculty. It's a little S-ish, but anyway, 5 faculty. So we got 22 plus 5 equals 27. So this denominator is going to be 27. We're choosing a group of people who get there as equals, so that's a combination. And there are 4 people on the committee. So what that's going to be is, it's going to be 27 factorial. The top will be 27 minus 4 for 23 factorial. And it'll also have 4 factorial. So we're going to have 27, 26, 25, 24, and 23 factorial. And down here we'll have 23 factorial. And then the 4 factorial is 4 times 3 times 2 times 1. I'm going to attack the 24 pretty actively. 4 divided by 4 is 4. That's 6. 3 divided by 3 is 1.
divide 6 by 3 for 2, 2 divided by 2 is 1, and that is gone. What we have here is 27 times 26 times 25 times 23, and that's the number of possible combinations we can have of people. I'll go ahead and grab any calculator to do that. You can use your combinations on here, you can use your factorials, but you've got to get this number, 27 times 26 times 25 times 23, 6, 27, 20, 27, 26, 25, and 23, 40, 3650. So each one is going to be 403650 in the denominator. Probably go to 5 decimal places, whatever it asks you to do. 3650. And you go an extra digit, and then you round off to the number of digits that you are actually requested. So what do we have to find out for A? We're going to find the numerators for each. For A, we have 2 choices going on. We have choices for students and we have choices for faculty. This choice for students is always going to be out of 22. Choice for faculty is always going to be out of 5. B is going to do 22, choose something, and 5, choose something, multiply. C is going to do that, 22, choose something, times 5, choose something. And D is also going to be 22, choose something, times 5, choose something. And I didn't do the one with one faculty member, so I don't have all 5 of them done. Leave that to you. You should have some ability to run with the concept that we have here. Fill it out, find out all the probabilities. They should add up to 1. Because it's the complete set of them. Okay, in this one, all faculty members, that's 4 for the faculty and 0. No faculty members. 0 for the faculty, but 4 for the students. 2 of each. 2 and 2. 3 students, make sure the 3 goes with students, with your 22. And 1 goes for your faculty. Alright, so this is going to be 22 choose 0 and 5 choose 4. 22 factorial, 22 minus 0 is 22 factorial and 0 factorial. That's times, you got your 5 factorial, 5 minus 4 is 1 factorial, and 4 factorial. That goes out to get you 1. And this gets you 5 times 4 factorial over 1 times 4 factorial. Gets you 5. So you can put a 5 on that. Next one. 22 choose 4. Okay. 22 factorial, 22 minus 4 is 18 factorial, and 4 factorial. 22, 21, 20, 19, and 18 factorial. 18 factorial, and 4, 3, 2, 1. 18 factorials are gone. And I will go 3 has to go with the 21. 4 will go with the 20. And 2 will go with the 22. Anyway, 11 times 7 will get you 77. Let's just do it with the calculator. And you can use any technology level you have. 11 times 7 times 5 times 19. The denominator is 1 as before. 7315. Two of each. Alright. 22 factorial over 20 factorial and 2 factorial times 5 factorial over 3 factorial and 2 factorial. 22, 21, 20 factorial, 20 factorial, 2 times 1. Out are the 20 factorials. 11 times 21, 231. Three students and 1 faculty member. 3 students. So we got 22 factorial, 22 minus 3 is 19 factorial with the 3 factorial, and 1 for the 5 factorial with the 4 factorial and 1 factorial. We got 22, 21, 20, and 19 factorial. 19 factorial, 321 times 5 times 4 factorial, 4 factorial and 1. That's those, and we've got the 19 factorials. So cancel the 2 with the 20 for 10, cancel the 3 with the 21 for 7, and we've got 70 times 22. 1,540 times 5. So that makes 7,500 and another 200, 7,700. We're going for 5 decimal places. So we'll do each of these fraction values out to decimal notation. 5 divided by 403, 650. Don't hit divide. Well, hit divide when you don't want to do plus. Don't be hitting plus. So we'll try it again. 5 divided by 403, 650. This is 1.238696 to some power of 10. It says 1, 2, 3. Okay, it's e to the negative 5th. So if it was e to the negative 1st, that would be 1, 2, 3, 4, 5 decimal. So this one, when I go to 5 decimal places, 1, 2, 3, 4, 5, the 12 is going to become a 10, and I'm going to come out of here with 0.4 zeros and a 1. 7315 divided by 40365. 7315 divided by 403,650 equals 0.08122 and then a 1. 1, 2, 3, 4, 5. That 21 looks like 20. So I'm going to say it's 0.08122. And 231. Oh, 231. What's that? Oh, I got 231 and then times, I didn't multiply out these other ones, did I? Let's see. My badness. Some of it is improper. Let's see, the first one is okay, it's got both. The second one only has the first reduction. I didn't multiply by 5. I can fix that. I don't have to erase it all and say, oh no, what a terrible waste. I can now say that I need to finish this. That's what the 2315 was. This has to be multiplied by 5, that to the 0. That's actually still going to be a 1. And that one's going to be okay. I just didn't demonstrate that we had to multiply it by that. That led to bad news on the other two. This 22, I got that right here. The 231 I'm fine with. But that's times, when we look at this, I forgot to close out the canceling of the 3 factorial. This is 5 times 4 times 3 factorial. Which is going to get you 20 over 2, get you 10. So this is going to be 2310. Of course, that last one made 7,700 strictly from the 1540 times 5, and I did not, let's see, did I? That does look like it's okay. Alright. So that one we can live with. Let's get the decimals running out. 2310 divide 403,650. 0.0057227. 0.005,722. 22 looks like 20, so that's going to be 0.00572. Seems low. And the last one, 7,700. Divide by 403,650. 0.01, 0.019075. Finally. $75 looks like 80. 0.019080 would make that. Now I have concerns, so before we shut this down, I'm going to check. I know the setup is correct, and the setup is what so many people have trouble doing. I'm going to see what we get on each of these cases. First, I'm going to do 27, choose 4. Make sure that's good, that we got the right number for that. Here we go. 27 on the math key. Let's choose 4. 17,550. Okay, so that's where the problem is. We'll check the rest of them. I'm going to go back and justify why 27 choose 4 was done in, not like, hey, that's good. No, but to find out what went wrong with it. 27 choose 4 is 17,550. The numbers, when I looked at them, they weren't going to get to a total of 1 when I added in the one other one. I knew it was off by something. Let's check the other ones while we're here. We've got to look at, all right, I know that anything choose 0 is 1. You can know it, you can prove it, you can deal with it. But when we have all faculty members, that's going to be 5 choose 4. And 5 choose 4 is 1. When we have no faculty members, then it's 22 choose 4, and that's going to be, let's see, so that's incorrect. Let's take a look. Where is it? Oh, 22 choose 4, that's a big number. We've got 5 choose 4, and then that multiplied by 1, that is a 5. I like that one. When we've got 22, math, go to choose 4. See how we did on that one. 3715, that one is perfectly done. So you can bank on the top of B, top of A, both done well. Now 2 of each. Okay, so we're going to go with, we have 22, math, go to choose 2 times, then we have 5, go to math, go to choose, I'm going to choose 2, and that should get for us what? That was displeased. I don't know, I made the calculator angry. We'll try that again. The top is going to be 22 choose 2, 22 math, go to choose, down to choose 2, times 5 choose 2, 5 math, choose 2, enter. Do it again. Why so angry? This guy needs to relax. Alright, one more time. 22 choose 2 times 5 up. Alright. In both cases it didn't accept my typing in of the 2. 22 math, choose, enter, 2 times 5 math, go to choose, put in the 2, this time it went, and we get number 2310, which we have. So that's good, the numerator of that one's good. Now we'll look at the other one. So it seems like we have one error, that is the calculation of the denominator, which we will adjust, and we'll get all these answers back to where they should rightly be. Anyway, let's see about this last one. 3 students, 1 faculty member. 3, math, choose, no, not 3, clear that too. We are 22 choose 3, 22 math, get to choose 3, that's doing the number we have down here, times, oh, the 3 didn't, oh, it's not entering my values right, 22 math, choose 3, times 5 math,
choose, make sure the 1 shows up, and then hit enter. Bottom 7,700 for that numerator. Those numerators are all correct. I'm going to go now break down what went wrong here with purple. Let's see, we have 20. Oh, the denominator is supposed to be 27. Choose 4. Let me make sure I did that right. All right, 27, choose 4, proper denominator. Maybe we're all good. 27 is what we're going with. Enter. 27. Math. Choose. Enter. 4. Enter. 17,550. Okay, so the denominator is wrong. So what that means is each one of the denominators is 17,550. But all the work done on the numerators is valid work, and we had one slip up, and as you can see, one slip up can cause multiple problems to not be answered correctly, but if this were to happen on your exam, I could see you only made one mistake and I only have to downgrade one mistake rather than total incapability of achieving anything here. All right, so we know what the question was asking. We can also decipher it from the way those fractions are set up.